Hello, my name is Larissa, and I am an undergraduate at MIT. This video discusses the Bohr model. When an electrical current is passed through hydrogen atoms in a low-pressure sealed container, the container will emit a pink glow, and when this glow is placed through a prism, there will be 4 lines representing 4 specific colors of the visible spectrum. These are line emission spectra. Why is there only a specific frequency of the light given off? Why does it have a specific wavelength? This is explained by the quantum model. Whenever an excited hydrogen atom falls to the ground state, it emits a photon of radiation. The energy of a photon is equal to Planck's constant times the wavelength. The energy of the photon emitted is equal to the difference between the final energy of the hydrogen atom and the initial. So the energy of the hydrogen atom inside the gas chamber, its change in energy. So the change in energy of this atom going from an excited state where the potential energy is higher than the ground state, which is the lowest state of an atom. This change in energy is equal to the energy of the photon released. The fact that hydrogen atoms can emit specific wavelengths of light, only these specific values, means that the energy difference must be fixed. It must be a constant. Therefore, the hydrogen electrons exist only in specific energy states. The Bohr model of the atom has an atom with a nucleus. So this electron of the hydrogen atom has different orbitals of energy levels. The further away the electron is from the nucleus, the more energy in that electron. So you can see here that the electron in E2 has a higher potential energy than an electron in E1, and yet a lower potential compared to an electron in the third shell. In order for the electron to move to a state of higher potential energy, an excited state, the name of this process is called absorption. And what is needed is an input of energy to the hydrogen atom, and then this energy causes the electron to move to a higher energy position. So the energy provided to this atom allows its electron to move from shell 1 to shell 2, which is a higher energy state. When the reverse happens, it's called emission. During emission, the electron moves from a higher energy state to a lower energy state, releasing a quanta of energy. The movement of the electrons from higher state of energy to lower state is defined in specific series. For example, the Lyman series. In the Lyman series, electrons move from a higher energy state to the first electron shell. In a series in which the electrons move from a higher state of energy to the second shell is called the Bohr series. And when the electrons move to the third electron shell from a higher energy state, it's called the Absorption series. This concludes the video. And as a final note, the Bohr model does not explain the spectra of atoms with 2 or more electrons. It only explains one electron system, such as a hydrogen atom. It also does not explain chemical behavior